Hi, and welcome to this video. Now in this video we'll be preparing you for WAEC questions on trigonometry. Now I believe after this video you won't have a problem solving trig questions on WAEC. Now here we go. If tangent x, this is a very practical question. If tangent x is equal to 5/12, evaluate sin x plus cosine x. Now, how come you come across this kind of question, whether in the multiple choice questions or in the second part B? But anyway you find this, something in this nature. Now, all you need to know is that, first of all, they've given you tangent x as a fraction. Okay? Now, you've been given that as a fraction. That should give me an opportunity for you to know that, okay, tangent x is this. Now, at that point, I want you to remember what we call SOHCAHTOA. Where we have sine is opposite of hypotenuse, cosine is what? Adjacent of hypotenuse, same thing with tangent. Tangent is what? Opposite of adjacent. So we are going to be making use of a triangle, right angle triangle, in order to go about this. Now look at this. Let's draw a right angle triangle. Okay. Right angle triangle, let's say ABC. Alright? No, this is the right angle. So line AC could be said to be the hypotenuse side, which is the longest side. Okay, now we have the angle here, angle theta. There. Okay, in this case it's x. So let's call our angle. Let's call our angle x. Okay, so we have angle A, angle B, and angle C. So let's just give it a name, x, because of the question. Now, looking at this triangle, this right angle triangle, tangent is always what? Opposite over adjacent. So tangent x, where x is the angle, is equal to the line opposite to this angle is this line, AB. So tangent x is line AB. Is that okay? That's tangent x. Alright. Over opposite to this angle over the adjacent, over line BC. Very simple. Alright. So just know that since your tangent is opposite of adjacent, so tangent x, where x is positioned here, opposite over adjacent. What if the angle was here? You simply tell us opposite is here. Alright. Now, from the given question, we can see that line AB is equal to what? Is equal to 5, 5. One line BC is equal to what? It's equal to 12. Line AB is the numerator, that's 5. And line BC is the denominator, and that is 12. Okay. Now, we are asked to find sine theta and cosine theta. Now, to find sine theta, now at this point, our line AB will now become 5. They've not given us whether it's centimeters or what. Okay, so whatever the case may be, our line AB is 5. Our line BC is 12. Now, what is our line AC? Because from the question they said find sine theta and cosine theta. So sine always make use of the hypotenuse side, which is the longest side, line AC. So we need to find sine AC, the side AC, line AC, making use of the Pythagoras rule. Okay, and as the Pythagoras rule states that the square of the hypotenuse side, the hypotenuse side here is what? Line AC. The square of that side is equal to sum of squares of the other two sides. So we have line AB, the square of line AB plus the square of line BC, the square of line BC. So the square of the longest side, or the hypotenuse side, is equal to the sum of squares of the other two sides. Now, so our line AC will now become what? Let's solve this. We have line AB is 12, is 5. Line AB is 5, and the square of 5 is 25. Plus, line BC is 12, and the square of 12 is 144. Okay, so summing this, we have 169. Now, so line AC is equal to 169. Therefore, AC will now become what? Now, line AC will now become what? You know, the square root of both sides. This should be 13. Okay, the square root of this is 13. Now, normally it should be positive or negative 13, but due to the fact that we are looking for the magnitude, you know, the distance, or you say, yeah, the distance between this point and this point, it can be negative. So its magnitude, we take the absolute value of that distance of that number, okay, it will give us positive. So the absolute value, that's the line, AC is 13. So we can now have here that we search for line AC is 13. And you can see it's the longest side. So that's correct. All right. Now we're going to move over to our question. The question now says, solve for sine x plus cosine x. So at once, sine x would be what? Sine x will now be equal to opposite over hypotenuse. Opposite is line AB, that is 5, over hypotenuse is line AC, that is 13. The next thing is cosine x is what? Cosine x is adjacent over hypotenuse. Adjacent here is 12 over the hypotenuse 13. So the sum of these two tricks, sine x plus cosine x, will now become 5 over 13 plus 12 over 13. Okay. I believe you can now get your result to be what? 17 over 13. So that is the sum of sine and cosine. The result gives us 17 over 13. I hope that's clear enough. First of all, we observe the question. We know that this was a fraction and could be represented on a right angle triangle. So you position your tangent of an angle egg. After positioning your angle, you now determine the opposite of that angle is what? The adjacent is what? The hypotenuse is what? Okay? Now, you position it based on the trick, which has this. Okay, from there now, you can also solve for the remaining side using the Pythagoras rule. After which, you go on to substitute it to find the other two sides, the other two tricks. And you do your sum and you go away. Alright, that's simple enough. You can do this within a minute. Alright, let's move over to another problem. Now here's another question. Evaluate, without using tables, that cosine of 45 plus theta divided by cosine of 45 minus theta. Okay, evaluate this, given that theta is 30 degrees. Let's start at once. Given this, now I want to bring to you this identity, cosine of A plus B A plus or minus B. Now, if you are given the cosine of sum of two angles or difference of two angles, sum or difference of two angles, cosine A plus or minus B, this means cosine A cosine A times cosine B minus, if it is cosine A plus B, minus or plus sine A sine B. So cosine A plus or minus B is cosine A cosine B minus or plus. That means if the question was cosine A plus B, you would have cosine A cosine B minus sine A sine B. If the question was cosine A minus B, that would be cosine A cosine B plus sine A sine B. Take note of that. You're going to be using it here. And as well, also know that sine, well, that was not applicable in this question, but take note that sine of an angle, of the sum of two angles, A plus or minus B, is equal to sine A cosine B plus or minus, this one follows it, cosine A sine B. Just note that. Hope that's okay. All right, let's concentrate on this. So because of that, cosine 45 plus theta and cosine 45 minus theta, let's evaluate that. Now 45 has taken the place of A, so that will become cosine 45 cosine A times cosine theta. This is plus, so that will be minus sine A. A is what? A is 45 times sine B is theta divided by cosine 45, the denominator now. Cosine 45 minus theta, that will be cosine 45 times cosine theta. This is minus, so it will be plus sine 45 times sine theta. So, where our theta is what? 30 degrees. So we now put 30 degrees in plus theta. So doing that, we will have, this will imply cosine cosine 45 times cosine 30 minus sine 45 times sine 30 divided by cosine 45 times cosine 30. Just substituting 30 in place of theta plus sine 45 times sine 30. Okay. Now, what is cosine 45? Right? So cosine 45 is noted to be 1 over root 2, which is root 2 over 2. That's cosine 45 times cosine 30 is what? Cosine 30 is simply root 3 over 2. You can find that at 0.8660 minus sine 45 is what? The same thing as cosine 45. That is root 2 over 2 times sine 30 is what? Okay, that is 1 over 2, 0.5 divided by what? Now we go with the denominator. So that will become cosine 45 root 2 over 2 times cosine 30 is what? Just the same thing here, just this thing will differ. So that will be root 3 over 2 plus root 2 over 2 times 1 over 2. Okay, now let's evaluate. This root 2 times root 3 is root 6. 2 times 2 is 4. Minus root 2 divided by root 2 over 2. Root 2 times 1 is root 2. Divided by 2 times 2 is 4. Okay, same thing with the denominator. Same thing with 6 over 4 plus root 2. That's not a good root 2. That was a scared root 2. That root 2 is scared. Plus root 2 over 4. Let's continue. So I would say here, this, let's take the LCM of the denominator and numerator. We have root 6 minus root 2 all over root 6 plus root 2 over 4. Now, this would imply that we have root 6, this and this cancels out. I have root 6 minus root 2 over root 6 plus root 2. This, I can say this should be the end, but we still have some things to do here. Now watch, if it is a multiple choice question, there's how you solve to this point, and you don't find this in the options. That simply means there is still something to do. So what can we do here? Now, here we have not simplified this completely, in that this is still in disodic form. The denominator here still has roots, so we have to eliminate the roots in the denominator by rationalizing. So I'm going to say multiply the numerator and denominator by the conjugate of the denominator, because I want to get rid of the roots from the denominator here. So I'm going to multiply by the conjugate. This is the conjugate of the denominator is root 6 minus, this was plus, so the conjugate of this is the minus of that, just minus root 2 divided by root 6 minus root 2. Alright, so we now multiply this bracket with this one with this one. So this would imply what? What are we going to have? Root 6 times root 6 is root 6 squared, that is 6. Okay, negative root 2 times negative root 2, that is positive root 2 squared. That will be what? 2. Okay. Now, in short, this alone, let's take it step by step. This is the same thing as this, so their product will produce their square. That will be root 6 minus root 2 squared divided by this and this. Now you can see that you can observe difference of two squares here. This plus and this minus. Alright, so we just go about with it. You say root 6 squared, that is 6, minus root 2 squared, that is 2. Okay, this will produce what? That will become root 6 squared. Expanding this, we will have 6 plus 2, you can do that, minus 2 times root 6 times root 2 all over 4. Need me clean from here. So let's simplify this. Simplifying this, alright, 6 plus 2 is 8. Minus 2 times root 6 times root 2 is root 12. Divided by 4. We are done with this. Now, the root there can be simplified further. That will be 8 minus 2 times 2. Root 12 is 2 root 3. Okay? Over 4. Root 12 is root 4 times 3, which is root 4 times root 2. So root 2 is what? Root 4 is what? Is 2. So that's 2 root. Sorry. Root 12 is root 4 times 3. So square root of 4 times square root of 3. That's what we can split this to. That becomes square root of 4 is 2. Square root of 3. 2 times square root of 3. That is 2 root 3. Okay. Now, since root 12 is that, we now have here, 8 minus 4 root 3 over 4. So we can simplify. And what's common? Sorry, we can factorize something. Let's factorize 4. So taking 4 out, we have 4 times 2 minus root 3 divided by 4. So this can cancel out. We will now be left with 2 minus root 3. Yeah. Check this out. It must exist in one of those options. Oh, this seems to be very much. Yeah. It's a complex problem. If this problem comes in Y, I believe it will be in the part B. But I hope it's simple enough. It's not much. It only takes time.